Alright, so in this video we go over section 5.1 polynomial functions, adding and subtracting polynomials. But first of all, in this section we are going to define what a term is, what a constant, a polynomial, monomial, etc. Identify the degree of a term and the degree of a whole polynomial, and then we are going to combine like terms by adding and subtracting, and then we're going to consider polynomials as functions that we can evaluate at certain values. So let's look at a few definitions so we can work with polynomials. Number one, let's define what a variable is. A variable is a letter such as a, b, x, y, and z. The most common one is x, and that represents an unknown number or an unknown quantity. A constant is a fixed value. In this case, a number like 5, 15, 30, etc. A term is a number or the product or quotient of a number and one or more variables raised to powers. The coefficient is only the numerical factor of a term. A polynomial is a finite sum of terms in which all variables are raised to non-negative integer powers, that is, only positive integers, and no variables appear in any denominator. Otherwise, those are going to be rational expressions, which we are going to look at later in the semester. And finally, the degree of a term is the sum of the exponents to the variables contained in the term. Okay, so let's look at some examples. I determine the degree of each term. So the degree is the sum of the exponents contained in all variables. Well, in this case, we only have one variable, and that variable is raised to the second power, so the degree of this is 2. The degree of that term is 2. Letter B, so we have negative 2 to the third power times x to the fifth power. So be careful here. Don't let this little 3 fool you here, because all we look for the degree of a term is only the variable part. If you want to simplify this, well, this is negative 2 to the third power. This is the same as negative 8 x to the fifth power. And the degree right here is 5. So the degree is 5. Okay. Why? Well, in this case, we have an invisible power, the invisible number, which is a 1. So the degree is 1. For letter D, we have now more than one variable as factor of comprising this term. Well, notice we have x, y, and z. So in this case, if we go back to the definition, the degree of a term is the sum of the exponents on the variables contained in the term. So we're going to add all the exponents, the number 2, this invisible 1, and that number 3. So 2 plus 1 plus 3, that's going to give us a 6. So that's the degree of the term. Alright, so, and for letter E, we have 5.27. Well, that's simply a number. And in this case, the degree is 0. So for just a constant, for just a number, we have the degree, because how can we explain this? Well, this is the same as saying 5.27 x to the 0 power. So the degree is 0 because x to the 0 is 1, and 1 times 527 is 5.27. Okay. Final answer. Let's look at the next page, see what we have. So we need to define what the degree of a polynomial, okay, the degree of a polynomial is. So the degree of a polynomial is the greatest degree of any of its terms. Okay, before identifying the degree of a polynomial, let's look at some ways to some vocabulary to look at the different kinds of polynomials. So in this case, a monomial, a monomial is a polynomial consisting of one term. Mono, the prefix mono here means one, so monomial is one term. Binomial means two terms. The prefix bi would be binomial. Trinomial, tri means three terms. Three terms. Okay, and of course we can keep going. We could keep going with more terms like tetranomial. Oops, doesn't work. Maybe we can call this a tetranomial. Pentanomial. Hexa. And so on and so forth. So tetranomial for 4 terms, pentanomial 5 terms, hexanomial 6 terms, decanomial, icosanomial, and centinomial. What do we have? Well, 10 terms, 20 terms, 100 terms. Of course, we're not going to work most likely with something like this, but if you were to follow the nomenclature, if you will, for polynomials, we would go with the Greek prefixes. Okay, so but still we're not going to use the term tetranomial and so on and so forth. So typically the ones that we use are monomial, binomial, and trinomial. Anything bigger than trinomial, we just call it polynomial. Okay. Alright, so for the next example, determine the degree of each polynomial and also indicate whether the polynomial is a monomial, binomial, or trinomial. Okay, so let's identify the degree first. So going back to the definition at the top of the page, so the degree is the greatest degree of any of its terms. So in this case, if we name the degrees, this is degree 3 because the power of the variable is 3. This is invisible 1, the degree is 1, and well, in this case it's just a constant term. So the degree is 3, and in this case the classification, we're going to classify it based on the number of terms. So we have 1, 2, 3 terms. That's a trinomial. Letter B, we'll look at the variable. In this case, the only term that has a letter is the letter n. And if we circle the power, well, in this case, the degree is 4. And we have, in this case, 1, 2 terms. So this is a binomial. Binomial. All right. Something like letter C might be a little bit tricky because we have a lot of letters, a lot of numbers, but again, the degree will come from the sum of the variables that appear in every single letter, in this case every single variable. So for example, the overall degree of this first term is the sum of these exponents, 2 plus 3, which is 5, plus 4. This is degree 9. In the second term, we have the powers 1 to 1. If we combine them, this is a 4th degree. If you feel more comfortable, you might want to, of course, add these invisible ones. Let me use a darker color so it looks better. So you might want to do this. So you're going to have x to the first, y to the second, and z to the first. at the powers up to 4. And x, y, z, x is raised to the invisible 1, y is raised to the invisible 1, and z is raised to the invisible 1. So this is degree 3. So in this case, the degree of the polynomial will be that of the largest one, which is 9. And the classification, because we have 1, 2, 3 terms, notice we don't not this is going to be a trinomial. So in this case, well, this is a trinomial not because we have 3 variables x and y, but rather because we have 1, 2, 3 terms. All right. Letter D, the degree. Let's have a look at the degree of that one. Well, so x, y, z is x to the first, y to the first, and z to the first. If we add up the degrees, the overall degree is 3, but in this case, we have only one term. That's why we would call it a monomial. And then letter E, which could look similar to letter D. Well, the overall degree will be that of the powers of every single term, x to the first, y to the first, z to the first. So in this case, the degree is 1, it's the highest, not the addition in this case. The addition is only done when they are multiplying, like in this case, like in that case. But in this case, the degree is 1, the degree is 1, the degree is 1. Well, the overall degree is 1. And in this case, we have 3 terms. This is a trinomial. All right, let's keep practicing on this. So let's find the degree of each of these polynomials. Well, number 1. Let's write the degree. So we're not going to name them whether they are binomial, trinomials, etc. We just find the degree. So x, y, this is degree 2. X squared, y squared, we add 2 plus 2. This is a degree 4. And this is a degree 2. And this is just a constant term. It's a degree 0, if you will. So the largest wins. So this is degree 4. Let's look at the second example. So we have x cubed times y to the first power. If we add the powers, this term is overall power 4. We have x cubed y squared. If we combine 3 plus 2, that's a 5. And then this is y to the fifth. This is 5. So the highest degree, well, that's going to be degree 5. Okay, so let's look at the next page. Let's see what we have there. Combining like terms, finally. Now let's do operations with this polynomial expressions. Well, let's look at very important definition. So terms are considered to be like terms, all right, if they contain exactly the same variables raised to exactly the same powers. So how are we going to do that? Well, let's see. Let's find out. So we're going to use highlighters here to help you out with visual ways so we can have a better understanding of this. So simplify by combining like terms. So we're going to combine like terms if they have the same variables raised to the exactly same powers. Like in this case, I'm going to highlight like terms. So I'm going to highlight with pink the x squared terms. So all we do is combine the coefficients. That is negative 12 add 7. I'm going to get negative 5. And this negative 6, just carry it. Let's do the same for the next example. Well, let's identify the like terms. So notice we have xy and xy. How about we highlight those? But we also, in this case, we have x and x. So you might want to combine those together. So let's use a better color here, something better looking. So this is going to be x and x. All right, so we have, let's see, whoops. So 3xy plus 5xy, that's going to give me a total of 8xy. And the green ones, that's going to be negative 2x minus x, that's going to add up to negative 3x. Final answer. Let's apply this. Let's apply what we did with example 4 on examples like number 3 here, example 5. Add the following polynomials. And typically we will be given these examples like this. One polynomial in parentheses plus, or incidentally as well, could be having them subtracting. Okay, well, in this case we are going to add them only. All right, so let's see. So for the first term, all we do is for adding polynomials, all we can do is simply get rid of the parentheses. Okay, plus x minus 3 plus x cubed minus 10x plus 5. So we can just do that. Now, what are we going to do in this case? Well, so what I like doing when working with adding and subtracting polynomials, because we're gonna combine like terms. So by like terms, we look for the terms that have the same variable raised to exactly the same variable. Like in this case, I have x cubed. So I have x cubed. I'm going to draw 3 bars below the x cubed to identify that this is a degree 3. It turns out I have another one here to combine it with. So now I'm going to go a lower power, x squared. So I'm going to write 2 bars to denote that this is a square term. And I don't think there's another square term, so that's about it. For x to the first power, I'm going to have only 1 bar. Okay, I'm going to have only 1 bar. And for constant terms, I'm just going to draw a wiggle here. And then I'm going to combine the like terms. So I'm going to combine 11 plus an invisible 1, if you will. Yes, you see this, there's no number in front of the x cubed. It's understood to be a 1. So that's 11 plus 1, that's a 12x cubed. I'm going to go with the square term. So negative 12, well, that's the only one. So we don't combine with anything else. Now I'm going to combine the x's. So I'm going to have 1x minus 10x, that's a negative 9x. Then the negative 3 plus 5, that's a positive 2. Final answer. We're done combining like terms. Let's do another example. All we can do is simply get rid of the parentheses. Plus 6x cubed y minus 10x minus 4. Well, in this case, I'm going to use a different way to group these terms. So because I don't have just like power 3, power 4, so in this case, well, I have powers of x and y, and notice this one right here, I'm going to group it with, I'm going to box it, and I'm going to box this one with that one. Do we have other kinds of like terms? Well, let's see. So the only other like terms are going to be these 11s. I'm going to circle with orange. I'm going to circle the 11 and the negative 4. Notice I have negative 10x, but I don't have other term that has only x. I have this xy cubed, but I don't have any other xy cubed terms. So the only ones that we combine are the ones that are inside of the box. 7 plus 6, that's 13. And well, these other terms, I'm just going to carry them and combine 11 minus 4, which is 7. So final answer. Okay, final answer. Now let's look at the last example of this page. So let's see what about it. So let's get rid of the parentheses first. 3a cubed minus b plus 2a minus 5 plus a plus b plus 5. Okay, so let's see. We have a cubed. We don't have any other a cubes, so this one is going to be about it. Now look at the b's. We have negative b and positive b. In this case, the b's are going to get cancelled. Then we have 2a plus 1a. And finally, on the other hand, we are going to have the following case. Notice how the 5's, negative 5 cancels with positive 5. So the only remaining terms, the only surviving terms are going to be 3a cubed. And in this case, 2a plus a, that's 3a. Final answer to this. Now let's do, for the next page, let's work on subtracting polynomials. And in this case, you might want to pay special, very special attention. All right, so how do we subtract polynomials? Well, typically the first group of terms, which is in parentheses, has nothing in front of it. That means it's positive. So all we do is simply write it down without parentheses. But in this case, when it comes to having a negative in front of it, well, what's going to happen here? We are going to use the distributive property to, so distribute the negative sign. That is, change the sign of all terms inside of the parentheses. Alright, this is what we did. This is the key here. Alright, so that's I want to put stars around. Okay, so that's the trick of the trade here. Okay, distribute the negative sign. When you do that, basically all terms that we have inside of the parentheses change sign. So this positive 7x squared becomes negative 7x squared. This negative changes to positive 5x, and this positive 4 becomes a negative 4. And then from there, we're ready to keep going. So in this case, I have squares and squares. I have first power with first power and constant term with constant term. So let's go ahead and combine those. 3 minus 7, that's a negative 4. And then 5x plus 5x, that's a 10x. And then negative 2 minus 4, that's a negative 6. And we're done with this one. Let's do the same for the next example. So notice the first group of terms inside of parentheses have nothing in front. That means we can simply rewrite it without parentheses. But it's not going to be the same case for the second group because we have a negative. That's going to make us replace or change the signs of all terms inside of the parentheses. Alright, so this negative becomes a positive 3x, not x, z to the fourth power, and then this positive becomes a negative, and this positive becomes also negative. And let's combine like terms. Well, what do we have? So we have a term to the fifth power. I'm not going to highlight it because that's the only one term. What about cubed terms? Do we have another cubed term? Well, of course. We have this one right here, 3 bars, and we have another one right there. So negative 12 minus 1, that's going to give us negative 13, but in this case, well, the negative 13. And then I have this z and negative 12z. That's going to give us negative 11z, and I have this remaining term which is 3z to the fourth power. And even though this is correct, I mean, when you do the homework on MyMathLab, or if you were to submit this work on an exam or something on paper, that'll be okay. But the only thing we do here is to write polynomials in descending order of powers. So in this case, what we're going to do is write this 3c to the 4th power in the place of the negative 13c cubed. So we can have something like this. Final answer. See how we have descending order of exponents: fifth power, fourth power, third power, and first power. All right, this concept checkpoint. Be careful here when reading, subtraction of terms in words. So one thing to keep in mind is, so if we subtract 2 from 8, the difference is. So in this case, we are subtracting 2 from 8. That is 8 minus 2. That's going to give us a 6, positive 6. But on the other hand, if we subtract 8 from 2, the order of the difference is going to change. So 2 minus 8, that's going to give us negative 6. So in other words, the order of the subtraction matters. And well, I have a duplicate word order. All right, so you might want to just cross it out. All right, so this is going to matter because when you do the homework, you're going to look at something like this: subtract humongous mess from humongous mess. All right, so let's see, how are we going to deal with an example like that? So from, notice the one that has the word from is written first. Notice the example we did here. Subtract 2 from 8. This is the from. Subtract 8 from 2. The one that says from, that's going to go first. So in this case, I'm going to have 10x cubed y squared minus 7x squared y squared. and I'm going to subtract the quantity 4x cubed y squared minus 3x squared y squared plus 2y squared. Alright, so what are we going to do here? Again, the first group of terms will have only 10x cubed y squared minus 7x squared y squared. And this negative sign, what we're going to do is to change the sign of everything. Yeah. So minus 4x cubed y squared, negative, negative, so this negative becomes a positive 3x squared y squared, and this positive becomes a negative 2y squared. So let's combine like terms. I'm going to highlight like terms. I'm going to highlight this in pink, because if you observe these two terms, we have the exact same variables x and y, and also raised to the same powers 3 and 2 respectively. On the other hand, let me get another color here. Hopefully orange works. I'm going to highlight these two. Alright, because in this case they are like terms, because we have the exact same variables x and y raised to the same powers 2 and 2 respectively. So all we do is combine 10 minus 4, that's going to give us a 6. That's a third power. And then negative for the orange ones, I'm going to have negative 7 plus 3, that's a negative 4, x squared y squared. And don't forget about this like term, this last term, which in this case it didn't have another term to be combined with, so just carry it. Just carry it over. Final answer. Alright, so that's pretty much it about adding and subtracting polynomial expressions. So now let's look at polynomial functions. Well, keep in mind that when we evaluate, by evaluate we mean plug in the x value. I want to recall this part from the previous chapter, in which we covered a very brief intro to functions. So given this function p of x equals 3x squared minus 2x minus 5, let's find the following: p of 1. So in this case, when we evaluate p over 1, this is telling us that x equals 1. So we need to plug in 1 wherever we see the letter x. So this is 3 times quantity squared minus 2 times quantity minus 5. And that's a 1. That's a 1. So keep in mind PEMDAS, we do the exponent first and then the multiplication. So 1 squared, which is 1, and then that 1 times 3, that's going to be 3. And then negative 2 times 1, that's a negative 2, and then just carry over this negative 5. And then from here just simplify this, so that is going to be 3 minus 2, which is negative 1, which is positive 1 actually, minus 5, which equals negative 4. And again, when we evaluate a function, this means y equals negative 4, or it means the order pair, the point on the graph of this, which is 1 comma negative 4 on the graph of p of x. Let's do letter B. So for letter B, what do we have? We have that x equals to negative 2, and we're going to have 3 times quantity squared minus 2 times quantity minus 5. And well, we're going to plug in the number negative 2. Okay, negative 2. So let's evaluate this separately. Be careful here with when it comes to this quantity right here. So when we have negative 2 squared, that equals positive 4, right? Because negative quantity squared, it becomes positive for this reason, because this is the same as saying negative 2 times itself. So 2 times 2 equals 4, and negative times a negative equals to positive. Alright, so in this case we're going to have the following: 4, this quantity becomes a 4 times 3, and then in this case negative times a negative is positive, 2 times 2, which is 4, and then minus 5. 3 times 4, that equals to 12, plus 4 minus 5, which in this case this adds up to 11. Alright, so this is the end of this section, so I will see you on the next video.